Not just software? Why not just software? That's the eternal question. Why not just software? Intel chips, motherboards, CPUs, honking CPUs, motherboard. That's all great. Enough memory, more silicon for everybody. Why not just do it in software? Well, it just simply needs too many cores. That's the simple answer. And I'm very sure the silicon vendors will tell you all about it. So we have it solved, or we have it working. And as Frank mentioned, in some places we have it even up and running live on the critical path. But that is only for 10G. So 4 million packets per second per core. Yes, even with DPDK. That takes care of like 4 million packets. For 10G, it should be 14.4 for comparison. So it's 1/3 per core. So you need at least 2, or I have further math. But it just doesn't scale to 25G, 40G, 100G. So that's why no software. So what's the big deal? Just add more CPUs. What's the big deal? Intel's going to come out with another chip. ARM has 64-byte. Red Hat works on ARM 64-bit. No problem. Just add more CPUs. Sure. So if forwarding 10G of traffic, like full 10G termination takes 4 cores, and if storage takes another 2 cores, that's 6 out of 24. That's 1/4 of a chip, 1/4 of the core. Yeah. And that is wasted revenue for a cloud provider, because they are not running the application. They are not running the kiosk. They're not running the travel application on it. They're not giving it away, because that core is being used for just terminating traffic, network traffic, and storage. So that's wasted revenue for the cloud providers, because they charge per cycle per second. And we learned it the hard way, because in one of our older releases, Network Manager, which was talked about earlier, that just used to remain on in the background, making sure that there are no DHCP requests, etc. And that was a non-starter for cloud guys, because they said, oh, this runs in the background, but it chews cycles. So we made it more a la carte and more nimble, that in server environment, it doesn't have to do that. But we found out that they are literally charging per cycle per second. So let me start to get to the crux of the matter. That was the foundation. So as you know, as software matures, as protocols mature, as RFCs mature, the hardware vendors and the silicon guys start putting that stuff into silicon. So that is where we are at now. So for the last 100 years to the last 10 years, it was all hardware. Imagine those ladies putting the switches, etc. That was all hardware. Cisco, Juniper, they made tons of money, truckloads of money selling custom hardware. I was in Siemens, part of a 320 million euro project for 40,000 calls gateway, media gateway. So it was all hardware, custom software. Then came Nigeria, VMware, others, Intel themselves, DPDK. Last 10 years, it's like all software. We can do it on software. We don't need custom hardware. That changed the whole dynamic, very disruptive technology. But now the pendulum is shifting towards somewhere in the middle. Very near future, some hardware, some software. That's what my belief is. Okay, with that said, Netronome. So as you can see, the bottom flat line at the bottom, which is the orange line, that is the software-only solution. So that is OVS DPDK running on XL710 Intel card. That is the bottom, that is the line with software-only solution. It takes a lot of cores, but that is the packet rate. And then the dotted line, that is the dotted line, which is really tall dotted line, is the theoretical max for 40G. But Netronome's numbers with hardware offload, you can see the solid blue line. So their performance is almost theoretical or very close to theoretical for most of the numbers, and is definitely higher than the software-only solution. But that graph on the left, the big graph, is not the key graph. The key graph is on the top right, which shows the CPU consumption. So the killer graph on this slide is the OVS vSwitch CPU utilization. So with the Netronome blue, tiny blue graph, that all that red CPU is relieved. So that is all the impact, all the processing from the motherboard is taken on the NIC, and the NIC is doing that processing.
You benchmark every SmartNIC. So do you think which SmartNIC is better?
Hold on, where's the trap? Let me see. So the question was, we benchmarked some and not a lot, which one is better? Yes, please ask the hardware vendor. That's a very good answer. Thank you. Please ask the hardware vendors, they'll get you a better answer. No, the thing is that the race is in the middle. In my opinion, if you really ask, we are in the middle of the race. The marathon hasn't been won. The finish line is way over there. So if my assessment is whoever gets to that list that I put out first with decent performance will definitely naturally be the natural winner. Because we are not only doing fast processing, we are relieving, and all of this checklist that everybody talks about, it's also done. Now, next, so that will be the clear winner. So most probably in the next 6 to 9 months, maybe in the next 9 months, let's say 0 to 9 months, the clear leaders will start emerging. So hold that question. Ask me again next year. Cheaper or more expensive than in dollars terms or some other cost? Cost of power? I haven't done that math, but I'll tell you that I was surprised when I found out the prices of these SmartNICs. Pleasantly surprised. I assumed they are in like $10,000, $30,000 range. They are not. I don't know the prices, so I won't even tell you. But I think if you find out about it, you will be also pleasantly surprised at how affordable they are.